you, all of you, for being here. And it's a pleasure for me to be here today to talk about this work. This is my last work, what is working on during the approximately 4 months ago. And the idea is trying to present today what is my preliminary results and try to discuss and receive some comments, suggestions, and trying to understand what the data said. This work I'm calling Deforestation, Watersheds Governance and Development, the Hydrological and Economic Consequences of Forest Loss in Tropical Basins. So, let me start with the motivation. Maybe you know, Colombia is one of the most biodiversity countries around the world, and that implies that the Colombia ecosystems are both economically and environmentally strategically, and forest is one of these key ecosystems that provides some ecosystem services that are useful for the hydrological process. So by influencing water infiltration, storage, and runoff within the watersheds, also this ecosystem is helping to maintain the water availability during dry periods and moderate rainflow during the intense rainfall events. And this is an important way because maintain or have a reliable water provision is essential for agricultural, household consumptions, industrial activity, and hydropower generation. So the idea or the main idea here is that this hydrological process has some consequence when it's not regulated, so this is not controlled. We know that we will experience these some extreme events more frequently in the next year, so we need to find ways to address them. Fortunately, some ecosystem like this forest provides some protection or some essential services that help to curb the impacts that come from the variation from these hydrological consequences. For example, during the droughts, we have that reducing water availability affect agricultural, household, industrial productions, and hydropower generation become more vulnerable to water shortage. Like, for example, Colombia and Ecuador facing the last years ago when some energy and water rationing was frequent during these periods. And on the other hand, during the extreme rainfall, we can see many times some flood and landslide that disrupts transportation network, and this implies that this infrastructure, crop, housing, and livelihood are damaged. So, in general, these tropical ecosystems face simultaneous pressure. That is important because when we realize that the climate risk and anthropogenic pressure intensifies, the economic value of ecosystems-based regulation and natural infrastructure become more and more important. So some pressure here, for example, climate shock, increase the frequency and intensity of hydrological extreme events. For the case of Colombia, these events are more concentrated in the droughts than for the floods, and the intensity is more concentrated in the southern part of the country, extending even toward the central area, characterized or composed for Amazon Basin, Colombian Amazon Basin, and also the Andean regions. Another pressure is the agricultural expansions. We say here that rising demand for agricultural land continue to convert the natural ecosystem, increasing pressure on forests and reducing the watershed capacity to regulate hydrological. And this pressure allowed me to introduce another pressure which is the most critical pressure in the region, which is deforestation. And as we can see here, we know that the areas where the deforestation is higher are areas where the use for agricultural purposes is higher as well. And the trends is similar for both deforestation and planted areas measured in hectares. So, sorry. And yes, with here in mind, I would like to highlight another topic, another element here which is the hydrological connectivity, the watershed connectivity. This element is important for this project because here we have these two figures. The figures on the left, we have the local stream flow anomaly, or in one gap local stream flow anomaly, and we have one step downstream anomaly. So here we can see, we can see that what happened in a local area is propagated through to another area downstream within the same watershed. And these figures on the right confirm this idea or support this idea. And we compare here what happened in a local stream flow cells against what happened in the average of the watershed as a whole. So what happened in a cells is basically the same what happened in the average of the basins. And that's allowed me to conclude or to go, to the idea that if if we have, or there is this connectivity among the different areas, sub-areas within a watershed, we have concluded that, for example, land use as well are dependent or interconnected among them. And the important topic here, or the implication about that, is the land use decision by the landowner typically don't internalize these downstream costs generated by the deforestation, for example. So this contributes to the typical negative externality problem in economies. And when these costs are not included or not taken into account in the measure of the deforestation, we can say that this cost is underestimated. What we typically measure when we talk about deforestation is usually forest cover loss, biodiversity impacts, carbon emission, and local land use change. But this measure overlook what happened in the downstreams. For example, changes in hydrological regulation, increase in flood and drought exposure, agricultural production losses downstream, and so on, broader socioeconomic consequence. And this leads us to the question of this research. Basically, I am asking myself what are the hidden downstream costs of deforestation, and to trying to answer these questions, what I do is basically to work on three interconnected dimensions. The first one, as the most directed mechanism, is how does the upstream forest loss interact with an amplified, nonlinear hydrological shocks. Then I analyze the impact of this upstream forest loss on economic development, physical risk exposures, and agricultural production losses. And finally, I analyze the mitigation and resilience, for example, asking about how the institutional governance help to reshape these impacts. The remaining of the presentation is as follows. I will continue with the conceptual framework about these institutional components, and then I will present the empirical framework, and finally we'll present the results and conclude. So let me introduce the governance and the an economic framework. Yeah. So what we have or we know about this problem is that the land use decision is driven by many incentives, a set of incentives, primarily economic incentives. And these incentives impact on the decision of deforestation. If each landowner takes the decision if deforests or conserves or maintain some forest cover. And then this decision has an impact on hydrological regulation and ecosystem service, depending on the amount of the forest cover we have. And if there is a chain of the deforestation area, the forest area and hydrological regulation and ecosystem services these forests provide, we have an economic vulnerability and a climate resilient impact. So we need to wonder or asking here, what could be the roles of the institutional governance in this chain of the results? What basically we have is these environmental institutions could help to modify the land use incentives to try to internalize the private costs and closely in this to the more socially costs about the deforestation. So the case we come here to bring with me in this presentation is what we know about the PONCAS. PONCAS is basically watershed scale environmental zoning with this is a planning instrument that coordinates land use, water, and ecosystem management. These have a characteristic that this promotes on conservation and restoration activity regulations. This is binding land use restrictions. And the other characteristics we have is that the implementation is management by the regional environmental authorities, which is the more decentralized institution in Colombia. So, what data I use for analyze this problem? What I do is construct a spatial explicit panel from 2012 to 2020 and combining the high frequency geophysical data with administrative and institutional data set across multiple sources. For a hydrologic process, I use the data GLOFAS, the GLOFAS data. This allows me to measure the river discard anomalies, measure in cubic metric is here, you know. Sorry, let me check it. Cubic metric per second for each grid. in a pixel levels. And this data allowed me to reconstruct the rivet networks, identified as well the directions of water flow, and define the upstream and downstream relationship, and calculate the upstream drains, the drain for each grid analysis. And for deforestations, for the deforestation, I use data from IDEAN. IDEAN is the institution in charge for the monitoring for deforestation in specific, but in general is an institution who's monitoring any environmental issue in Colombia. And I use or complement this data with a rich data set for climate biophysical control, including precipitation, soil drainage, and terrain characteristics. And for socioeconomic and institutional systems, I use the data from SEDE municipal statistics, which allow me to have an historical data set of the municipal at the municipal levels. And I complement this data with some information for PONC and implementations, which I got from the National Ministry of the Environment, and as well I use data from Global Dam Wash database to trying to control for the effects that this great infrastructure could have on the hydrology. And for disaster, I use the data, the emergency registry for the national entity in Colombia. For the analysis, I follow this two-step approach. For the first step, I quantify the spatial externality. In this, I divided by two sub-steps. For the first step, I quantify the upstream, the impact of the upstream deforestation on the downstream nonlinear discard anomalies. Then I use these shocks or hydrological shocks to analyze how this shock affect the socioeconomic outcomes. And for the second step, I evaluate the institutional mitigation. Basically, I use this or trying to answer what the governance could help to mitigate the effects of the land use on the socioeconomic effects, outcomes, And the idea is that this institution could break the degradation chain by restricting upstream land conservation. And finally, I complement this analysis using the causal forest to try to identify where enforcement capacity and geophysical features could maximize the policy return. In empirical manner, I use basically a two-way fixed effects. I don't like to spend so many time here. It is a standard two-way fixed effect where I use the grids fixed effects and time fixed effect to try to control for time invariance characteristics and common shocks across times. And for this outcome, nighttime lies as a proxy for economic activity. Maybe you know, trying to measure the activity at the level of the municipality is so difficult, especially in a developing country like is Colombia. So in the literature, specifically in economic literature, is well using this measure night lights as a proxy for this activity. So for the first substep in the second approach, what I do is using the same two-wave fixed effects models, but what I do is include some interaction with the anomalies of the hydrology anomaly with ponca, with dams, and soil drains. So my interpretation or my hypothesis is that ponca may reduce upstream deforestation and improve the watershed management. For dams, my hypothesis is this can regulate stream flow and reduce hydrological variability. And finally, for the soil drains, this could may influence local exposure and hydrological shocks. And for these elements or final elements about the governance, I use two approaches basically. Maybe one problem we have when I work on with poncas is this basically an endogenous problem. Maybe you know, when we work on protected areas or when we protect any areas, basically what we have or the government has is to have the birders results intention, no? So what happened with poncas instruments is maybe implemented it in areas, in specific areas, where the government has more willingness to protect, and the areas, while the areas where the ecosystem is no pressures, or the ecosystem doesn't have any pressures, the poncas is not implemented, or maybe the government has no the willingness to protect these areas. And this creates some endogenous problem. And to trying to address this problem, I use a staggered difference in difference approach to trying to exploit the staggered adoption of the poncas across the different zoning in Colombia. And the other problem or the other component of the analysis is that I would like to take into account the huge spatial heterogeneity could be in Colombia. Because, you know, this is an analysis doing at the pixel levels. So many regions has some characteristics different from another. So what I do is to trying to account for this high dimensional heterogeneity using this generalized random forest, and to trying to capture the conditional average treatment effect for each grid, for each characteristic of the grid and municipal layers. So let me go to the results. This is the first results. What I do here, or what we can see here, is effectively the upstream deforestation has an impact on the Q anomaly, the flood, and the drought. For the Q anomaly, we see here that the upstream has a decreasing effects on the Q anomaly. But for flood and drought, we have that the upstream deforestation increase the probability of facing one flood and one drought in each grid. So for local deforestation, we have that some effects, counterintuitive effects, basically for floods. This is an effect I would like to try to understand. Maybe you will like to help me to try to understand this measure of this estimation, because for Q anomaly is good. We have that when the local deforestation increase, the Q anomaly could decrease. For droughts, we have thus an increase in the local deforestation, increase the droughts. But for floods, we have that this local deforestation generates a decrease in the flood experience. So for me, it's some counterintuitive effects, but I am trying to figure out what could drive in these effects. And for great infrastructure, for dams, we have these dams has a buffer effects and significantly alter basically a localized base flow metric. For example, we have a decrease in flows, but we have a huge increase in droughts area. That is, if we have upstream dams, this generates that these dams, when we face extreme anomalies, the drops increase. This is the idea about this estimation. And another differentiation about these results is that, for example, it's not the same compare one area farther away from the rivers than area close to the rivers. What these figures show us is areas farther away than a river has less effects on the hydrological anomaly. But when we analyze the deforestation, the upstream deforestation in areas close to the rivers, the effects is more statistically significant, specifically in Q anomaly and the droughts. The upper row is for upstream deforestation, and the bottom is for local deforestation. So when we look at the effects or the heterogeneous effects of the soil drainage, we have that these drains has a sponge effect like that. You can imagine that the drains sponge or the sponge effect operate heavily on the extensive margin of the flood. So high drained soils successfully absorb the flash runoff that we see after an upstream tree forest loss. But these effects is dissolved when we control for precipitation total precipitation of the basins. So when we face extreme rainfall regimes, even the best drains areas suffer from rapid saturation thresholds. This is my interpretation of this result. Because as you can see here, when we face some extreme rainfalls, all the coefficients for drought and for floods are positive. This is an increase on the floods and drought, even any drains kind of drain of the areas. So for downstream economic outcome and disaster outcome, we have that this deforestation, upstream deforestation has an impact on basically on total disasters and on droughts. And this is mainly biased for the characteristics of the Colombians. As I show you at the first figures at the beginnings, the drought is more permanent in Colombia than the floods. So what we can see here is that this coefficient is capture these characteristics of the setting where we are analyzing the data. So the upstream deforestation increased the total disasters and the total droughts downstreams in the areas. And for agricultural channels, what we have here is that the effect is basically concentrated on the permanent crops. We have any effects or statistical effects on the transitory crops is mainly derived for the permanent droughts, with the idea is these crops maybe is more sensitive to the water anomalies than the transitory crops. And when we look to the idea or what is the attenuation effect for the watershed governance, what we have here is when we compare the result for upstream the upstream PONCAS aptives or the local PONCAP aptives, we have a differentiation among them. So difference among them, sorry. For the upstream PONCAS, that is when one area has PONCAS acted upstream for him, the effects is a reduction basically on the drought. But it's curious that we have also a statistical significant effects on the floods, similar what we got in the first estimations. And for the local PONCAS, what we have is that the PONCAS is more the local PONCAS is more effective in controlling or controlling the effects on floods, contrary of what happened with the PONCAS upstream. The PONCAS upstream is effective in controlling the droughts, while the local PONCAS is effective in controlling the floods effects generated by an upstream deforestation. And let me conclude or finishes with these results. As I say you in the methodological frameworks, these results is derived by some PONCAS endogenous active, no? But for trying to controlling for these effects, I use the staggered difference indifference approach. And what I do is to trying to see if the PONCAS has an effect on the local deforestation. And what we has is when the PONCAS is active, the total deforestations become decreasing, no? And for the causal forest, what we find is the areas where the deforestation is higher, the results, you can see the blue, dark blue stone is where the reduction by the PONCAS implementation is higher. So the blue areas is more concentrated in areas where the historical deforestation is higher in Colombia. So what we conclude for this is the PONCAS could work as a good instrument for trying to controlling the deforestation in the basins, so could help to mitigate the effects, the downstream effects that these generated. And this is another result. For example, we have for the nightlight growth, and the idea is, or what the model show us is the PONCAs contribute to the increase of the economic activity, maybe controlling for the economic damages generated for these deforestations on the hydrological process. And also we have the result for the probability of the floods and the droughts, and this map very well what the data shows and the model shows according to where is the more effective spatially distributed effects of the PONCAs. And let me go to the conclusion. So, what we have here is that the ideas what the findings say me about this problem is mainly the hidden costs of the deforestation stem far beyond for the forest frontiers. So the mechanism is clear for me at least at this moment. In the first step, upstream forest loss amplifies the hydrological shocks, and this generate an increase in downstream economic activities, the economic vulnerability across rivers basins. What more interesting for me conclusion about this is what we need to try to understand about the watershed management. It's if we have, or whether we have would like to have an effective watershed governance, the more the key pillars we have to develop in the watershed governments or management is for example to trying to overcoming the border fragmentation is no focus on the traditional administrative boundaries, but also we need to try to focus on the ecological boundaries. The second prediction, or the second conclusion, policy conclusion, is the shifting from crisis response to preventing targeting. Maybe we need to try to take advantage for these heterogeneous treatment effects and trying to identify where investments in watershed governance may generate the largest social returns, to try to improve the effectiveness of the policies in trying to fight against the deforestation and the hydrological processes, stream process. And finally, the governance to trying to understand the governance as adaptation infrastructure. What is clear here, we need to try to strengthen the local enforcements, the institutional coordination, especially the community-led basin committees, because it's often a far more adaptable and cost-effective climate strategies than building large-scale great infrastructures. So that is, thank you very much for your attention. I will welcome any comments, questions, and so on. Thank you so much.